We are putting on a GDevCon style meeting in Boulder, Colorado in October, provided we're allowed to. It should be fun. I don't know if any of you guys went to the regular GDevCon, but it was quite fun. It's like this, community driven, only in person, and so it's a really good time. I highly recommend if you're able to come that you come. Obviously, there are some considerations with this whole coronavirus thing, so we are going to start selling tickets September 1st. So we don't want to start selling tickets now in case, God forbid, something happens. We don't want to hold on to your money. So we're going to start selling tickets September 1st. So keep your eyes out for that. We are also still looking for sponsors. We should have enough presenters, but if you got an idea for a presentation, you can send me an email and we can talk about it and see if we can squeeze you in, because all of the presenters that we had might not be able to make it anyway. So, all right. Oops. And the website for that was gdevconna.org. We are not the same as the group from England. So we are a similar-minded organization, but we're separate. They were nice enough to let us borrow their logo and give us a bunch of other support. All right, so my goals for this presentation. One, I want to show you guys that we can take ideas from other programming languages and implement them in LabVIEW. And I think that's really important because I think a lot of the challenges we face have been solved in other computer programming languages. And so I think we should not be afraid to go grab those ideas and implement them in LabVIEW. For example, the idea of interfaces and object-oriented programming came from other programming languages. I want to discuss how mock objects are used, so what they are, how they're used in both testing, and then something I recently stumbled upon that you can actually use them as part of your design process if you're doing TDD, which I thought was a really interesting revelation. And then I want to look at some code and get a bit of a design review. I'm hoping Steven's in here and can tell me all the stuff that I'm doing wrong. And then get some advice on what direction to take this as far as upgrading it, because this was written in LabVIEW 2019, so it does not use the interfaces. So I think interfaces would be a huge help. I'm just not quite sure what the best way to mix and match and package that all together is. So I'm hoping, again, somebody like Steven or somebody else who knows a lot about LabVIEW classes and interfaces can chime in and at least tell me either I'm on the right path or tell me which direction I should take. All the source code and all the packages to install it and everything are here, gitlab.com/sas_public. The main repository is this class refactoring tools. It actually depends on two other repositories as well. So if you go to the SAS public route, you can see all those. And you might find some other stuff there that's interesting as well. I'll go back here for a second in case anybody wants to write that down and pull that up. This is going to be recorded, so you can get access to all that later as well. It might help to follow along if you've got LabVIEW open and you want to pull it up. All right. So mock objects and testing. So on the left, we have a VI that is just a simple addition. Right? So it's a simple mathematical function. For those of you who are into functional programming or listen to Piotr's talk, right? This is a pure function. It has no side effects or anything. It just adds two numbers. Right? It's very easy to test because we have inputs and an output that we can access from the connector pane. And all the stuff on the right, if you've tried to do unit testing at all, you know that databases, hardware, timing, serial port, network communications, file I/O, all these things are hard to test. I'm going to pull up the chat window, it looks like. All right, make sure I catch up here. Fab says maybe the new version of Karaya will be better than JKIVI tester. I don't know. I haven't checked it out yet. I did see that got updated, and I got an email from JKI about it. So, I think it depends on who you talk to. There are certainly lots of evangelists out there proclaiming that TDD is the thing to do, and there are plenty of people who are proclaiming that it's not the thing to do. And Stephen here is here as well. So, Yes, Fab makes a good point. Some things don't need tested. So low-level drivers, you can assume that the people who sent them to you tested them, right? So Visa, you can assume that NI has probably tested that. I think that's a fair thing to do. And there's also, I should mention, there's a lot of dispute over exactly what constitutes TDD as well. So we will get into that a little bit. So I think I'm caught up on the chat. All right. So why are these things hard to test, right? Well, if we think about it like this, we've got our test code, and it's calling the SUT. So SUT stands for software under test, in case anybody doesn't know that term. And it's using direct input and output, and those are the connector pane, right? So we can set some values in the connector pane, call the code, right? Pass those values in. We get a value back. We can compare it. That's great. But what if our SUT, the software we're testing, interacts with some other thing, some dependency, right? So DOC stands for dependent on component, right? So we've got a dependency there, and the SUT's interaction with that is hidden, right? We call those indirect inputs and outputs. So if the SUT's interacting with the database, and I tell the code I'm testing, hey, go store this record in the database, how do I actually know that it stored the data in the database? It just returns without an error, and that's all I have, right? So I either have to find some way around through the backdoor to access the database and verify that it's there. I have to do something else. And one of the things that we can do is a mock object. So what is a mock object? What does it do? Basically, it stands in for our dependency, and its main job is to just record every call, every method call that's made on that object, and all the parameters that are passed to it. And then it has some verify method usually that says, okay, you tell it what methods you expected to be called and what parameters you expected to be passed. And then it verifies that, yes, the software you're testing did make those method calls and pass the correct parameter. That's basically all it does. So if we go back to our original drawing, right, our test code talks to our SUT, the software we're testing. But the software we're testing, instead of talking directly to the dependency, it talks to the mock, which inherits from either the dependency or whatever interface the dependency inherits from, or implements, or whatever word you want to use, right? So from the software we're testing's point of view, the mock is the same as the dependency. It doesn't know the difference. And then the mock somehow has a way of telling the test code, hey, everything was called correctly or not. Okay, so that's how mock objects work with testing. How do they work when it comes to design? So this is something new that I just discovered like in the past couple weeks. So I don't have all this figured out yet, but basically, right, if we're doing test-driven development, right, and we're testing a piece of software, and we suddenly, as we're doing our test-driven development, we decide that, hey, we need to add this dependency, right? That dependency probably hasn't been designed yet. Okay, so Mark Bremer asked how to switch between the mock object and dependency. Dependency injection, yeah. So what I'm typically using is dependency injection. So either I have some sort of create or initialize method where I pass in the dependency, or I just have a property node that lets me set which dependency to use. And then I just use the inheritance hierarchy so that the software under test doesn't care which one. Yep. So there's a really great movie video presentation that Sandra Mancuso did at something called DevTernity. If you go look it up on YouTube, there are actually a lot of good presentations at this conference. I'm not going to make you watch it because you can see it's an hour long. But there's a link there. I highly recommend you go watch it because I'm going to bastardize the heck out of it. I'm going to try to explain it in about 10 or 15 minutes, and he takes an hour, and he does a much better job. But I'm going to try to hit the highlights. But before we get started, we got to really think long and hard about what our goal is when writing tests. And the big problem that happens with mock objects is if you're not careful, you end up testing the implementation. right? But our real goal should be to test the behavior. So anybody want to guess why it's better to test behavior rather than implementation? You can just throw it in the chat. Or if you want to unmute yourself and say it, I think you can probably do that. I don't think I have everybody locked. Implementation changes, yes. Okay, so yes, behavior should not change, right? Of course. So what's behavior based on? The behavior that we want is based on the requirements, right? We all know requirements change, but our implementation probably changes a lot more rapidly than our requirements, right? So if we test the behavior, then we're not going to have to update our tests constantly every time we want to change the implementation. That's the main reason. And as an example, the behavior we want might be, right, we've got a VI that does some calculations and we want to store the results and be able to pull them back out. Okay, well, when we start, that might be as simple as storing them in a shift register. And then we decide, okay, we need to store them, like, shut down the program and bring them back up. Okay, so the first thing might be to throw it in a file. And then you realize that that's too much data for a file, so you throw it in a database. And then you decide that, well, network database is too slow, so then we throw in an SQLite database, right? So the implementation has changed a bunch. The behavior is still the same. We want to be able to store that data and then retrieve it. So, yeah, Fab has a little smiley face with the requirements change slower than implementation. Hopefully they do. If they change faster than implementation, then you got real problems. All right. And so, there's a lot of discussion when it comes to unit testing about what is a unit. And the best description I've had is that Roy Osherov's a unit should be a unit of work. And I kind of think that a unit should be a unit of behavior. Now, work is like something you do, so maybe that is behavior. Maybe I'm like splitting hairs here, but I think thinking about it clearly as behavior, as opposed to I'm testing this VI or I'm testing this class or I'm testing this library. I think when you get to that level, I think then you're specifying more implementation because you don't really care about whether it's a class or a library or a VI that does this thing. You just want to make sure that this thing gets done, this behavior. So that's just a thought that I had when I was putting this together. Yes, Fabiola said that Roy Osherov has changed the definition in each edition of his book, and he's already working on the next edition. So, yeah. I think that just goes to the whole Agile thing of learning better ways of writing software, right? We keep iterating and coming up with better ideas. But it's hard to interface a behavior. Okay, I'd have to think about that one. Maybe you could be more specific, Michael. But so I do think you could have an interface that says, I pass you this data and I expect a result back. Right? It does some calculation. That's behavior, and you can specify that in an interface. I don't know. I'd have to ask you to explain your question a little better to make sure that I'm understanding what you're saying there, Michael. All right. Perfect. I will be happy to talk to you. You always have good and interesting things to say, so. Okay. All right, so this is a large part of Sandra Mancuso's presentation, the TDD evolution of a design. And this is classical TDD. So for those of you who haven't looked at TDD a whole lot, the basic premise of TDD is you write the test first and then write the code. That's like the absolute basic premise. But there are really two different schools of thought when it comes to TDD. And there's the classical, which is the Kent Beck, the original one. Sometimes I guess they call it like East Coast or Chicago School or something. And they don't really use mock objects a lot. And their thing is you write a tiny test and you immediately write whatever code you can to get the test to pass, right? And you do it as quickly as possible. And it doesn't matter how ugly it is. It doesn't matter if you're just dropping a constant on the block diagram to get it to work. You get to work as quickly as possible. You get that test to pass. And then you do your refactoring and make sure you don't break anything as you're refactoring. right? And that is one school of thought. And so it kind of looks like this, right? You want to add some feature or some behavior, right? That's the real word we should be using. And so you write a test to test that behavior. And that leads you to create a VI to implement that behavior. And then you decide, okay, well, I've got this other behavior. You write another test. And then you add more to your VI to then make that test pass. Pretty soon, as you start adding tests, that VI gets really big. And you decide, okay, well, I need another VI to do this other function, right? Because it doesn't make sense to cram all this behavior into one VI. And since these two VIs are doing something related, we decide to put them in a class. Standard so far. Right? We add some more behavior that we want to test. We write a test for it. We add it to one of the VIs. At some point, we have to add another VI. Right now, we've got several VIs in a class that implement all these behaviors that we want. Right? Each of these tests represents some sort of behavior. And at some point, part of the refactoring steps is you do some refactoring. Right? So TDD is a red, right? Write the test. If it fails, green, make the test pass. And then the next step is refactor. Right? So at some point we refactor and we end up with a bunch of private methods. So we got all these VIs inside our class that aren't exposed by the API. And at some point, the responsibilities of these VIs gets really big and we decide they don't really belong in that class anymore. Right? So we move them outside the class and maybe we put them in their own helper classes. Right? And so our unit of test then becomes, right, this class that we're interacting with, and all the helper classes are kind of included in the software under test, but we're not testing them separately, right? Because we're testing them through the interface that's provided by our class, right? So we kind of have like maybe a facade class if you're familiar with the Gang of Four pattern. We end up with something like this, right? And these helper classes are tested because they're exercised through the public API of our class that we're testing, right? And it expects that behavior. We have some problems, though. Changing the helper class could potentially break some of our tests. And why would we change our helper class? Well, maybe that helper class is so useful that we decide to use it somewhere else, right? So we use our helper class somewhere else, and it has a different need, and so we start messing with that helper class, and maybe we break something, right? And so the traditional TDD works really well when these helper classes are just used within the software under test, right? They're just used by that class. They're not used anywhere else, right? And it helps too when the thing is small, right? As it grows and you get more and more of these helper classes, it gets to be a real pain. So let's look at a different way. So there's a different school of design that uses mocks a lot, and they're called either Mockist or like London School or something. And so it's outside-in design. So the original TDD is you start with a really small test, you write some functionality to do it, and you do the design during the refactoring stage, right? So you make the test pass as quickly as possible, and you get this soup of code, right, that looks like crap because you implement it as quickly as possible just to get the test to pass. And then when you refactor, then you look in the soup and you see, well, where are the chunks? To Fab's thing, you find the meatballs and the spaghetti, right? And you start extracting things, and then your design kind of grows this evolution as you start writing more and more tests. Every test, you go through that refactoring thing and you start refining your design. For me personally, that's not the way my brain works. I identify much more with this outside-in design. So the idea here is you look at the problem as a whole, right? And instead of starting out by just writing a little test, you kind of do a little bit of design first. So you decide that the functionality, the behavior that you want is going to reside in a class or a library, depending on what your needs are. And you decide that this class is probably going to have a bunch of functionality related to one thing. And so you're going to put that off in a helper, right? And that helper is kind of part of the software under test, right? Because it's really tied directly to the class. And then maybe you have some other component out here that's maybe like domain specific or maybe like a database. Yes, Fabiola mentioned test-driven design versus test-driven development. And I think when I when she first told me that, I think I resisted it, and now I've totally come around to her point of view, I think. So so you decide that, hey, I'm going to have this database here, but I'm probably going to want to store other stuff in the database. So it's kind of a standalone dependency. It's kind of out there on its own. But then you think, okay, well, how do I write tests for that? And so you decide that you're going to include an interface as part of the software that you're testing, right? So you've got your class that provides the main API, maybe your facade, right? You've got a helper class or library, and now you've got this interface, right? And the problem is this standalone dependency, your database layer, is not designed yet. Right? Now you could go design the whole database layer and test it and do all that first. But if you want to let the design evolve a little bit, what you can do is create a mock object for that interface, right? And then kind of think about, what does the software under test actually need to do with the database, and how does it need to interact with the database? And you think about that as you're writing your tests, and you use the mock to just say, okay, my software under test needs to send this data to the database. And you make sure that all the logic in the software you're testing, right, formats everything correctly and sends it off to the database layer. And then the mock just tells you that, yes, all that data is formatted correctly and sent correctly, and that's it. And then later you come along and you implement the actual dependency. Is that kind of clear to people? So the mock kind of like, as you're growing your TDD, right? As you're growing the software under test, you're adding methods to the interface. And as you add them to the interface, you add them to the mock, and it lets you make sure that everything's flowing correctly. Does that make sense to everybody? Does everybody see how that's kind of different than the other way of doing things? I guess you could say that, Chris. A mock is similar to a stub that actually does something useful, yes. Now, if we go back to this previous slide, the problem is if this helper class is used somewhere else, okay, you might just say a helper class could be a loop construct. A mock is similar to a simulator. So the issue with the traditional way is, if, say, helper class A, right, we decide that's going to be a standalone dependency. Why did I just hit snooze? Hold on 1 second. I hit snooze. That's going to go off again in a few minutes. Sorry. Okay, so if we use that helper class in another thing, and we decide at that point that then we're going to create an interface and do the mocks, the problem is that breaks all your tests and all your tests on the left-hand side here, because they all expect not the behavior, but they expect the actual functionality to be implemented, right? So when you move it out of there, then you've got problems, right? So it doesn't really grow very well. And Stephen, I'm assuming that's Mercer. Simulator tries to process the activity and stand in for the thing. Mock just returns fixed responses. Yes. So that's something that's on my list of things to discuss, because right now, my mock object toolkit, and we'll get to that in a minute, it just records the calls and the inputs. It does not actually return any outputs. So it just returns whatever the default is. If you wanted to return outputs, you actually have to manually program that. It's possible to do that, but by default, it just returns whatever the default values are. And that's one of my discussion points at the end about how to do that. Simulators are also very useful, Fabiola. Yes, I think of a simulator as more interactive and more for like integration type testing, but okay. Michael is asking about evolutionary design, and I'm not quite sure. Are you saying that's what this is called? That would be the technical term? All right, so I think this is a point where we go to the demo, but here are a few points that I want people to keep in mind to think about as I'm showing you what I'm doing, and then maybe we can get back together at the end and talk about this. So the first one is handling outputs. A lot of mock objects in Python in particular, a lot of it's like manipulating the outputs. Now, there's a whole debate of terminology and stuff, so I tend to use the term test double for things that generate outputs. But mocks also sometimes need to generate outputs in order to drive through the correct paths. So the other thing is, and Mercer's the one who's going to have to answer this, is it possible to do this on the fly in memory? Because a lot of mock object frameworks let you do that. So you declare in the test, hey, I need a mock object for this thing, and this is what I want it to return for these calls, and it does all that in memory, and you don't have to create a separate class on disk and all that. And I don't know if that's possible at all. That requires more knowledge of the inner workings of LabVIEW than I have. And then the other thing would be interfaces and how to add those in and how to support those. My best bet, so the current version of this is written in 2019. I don't think it's using anything that couldn't be backsaved. So in theory, if I leave a fork in 2019, then anybody who wants to use it on any previous versions can backsave it. So that's my thought process on that. And then also just some refactoring tooling, because I feel like part of the TDD cycle is doing refactoring. And so it'd be really useful to have some tooling to extract an interface, right? So if you got a class to say, hey, take these 4 or 5 methods and create an interface for them. And maybe to split an interface, if you got an interface that's got like 10, 15 methods, you could say, make this 2 separate interfaces. So that's just some of the stuff that I'm thinking about. So we will come back to those questions at the end and maybe once people see what I'm doing. So if you go to that GitLab page that I posted at the beginning, it has a video and it shows you a demo. So I'm not going to go through the whole demo of how we got here. I'm just going to do a demo of this is what the end result looks like. Let me close this first. I got one step ahead of myself. Okay, I don't know what that's about, but okay, LabVIEW. This is the project I want. All right, so this whole thing started out because we have a test step that's part of some larger test framework. Steven says, how fly? You don't have to save the class to disk. Scripting can create temporary classes, but only works in IDE, not in runtime engine. Requires some code magic to create a class on the fly in RT with some specific responses based on a source, but it is software, it can be done. Great. Let's talk later, Stephen. Remind me and we will talk. Because right now I kind of view this as a somewhat heavyweight solution. But if you're interested in working on that and can get some support, Stephen, I would be happy to work on you with that. So, all right, so we have a test step that owns a DMM, and we're going to set the voltage, or set it to voltage, set the manual range, auto zero it, and then take a reading. Christopher Stricker says, is there a reason to do it in the runtime engine? Maybe for testing PPLs, I don't know. That's a good question. All right, so let's say we want to write a unit test that verifies that these steps are called in the correct order, right? Because if we called them out of order, it wouldn't make sense, right? If you were on current and then you set the range and then take the reading, you'd be getting the wrong thing. If you didn't auto zero, maybe that messes up your measurement, right? So we want to make sure that those all happen in the right order. So this is the unit test that we're going to create. So I've got my test step. I am setting the DMM here with the property notes. This is your dependency injection, whoever asked about that earlier. And instead of giving it the real Agilent DMM, so I have an Agilent DMM class here, right, that actually stores some information here, and it's got all the Visa information, everything. It actually makes the calls. Instead, I'm going to give it this mock DMM class. And it has a mock object helper that handles keeping track of all the calls. And that mock object helper is a by reference class, so I have to initialize it. So I call the initialize, and this creates my mock object helper and stores it in there. We'll get into that in a minute. And I pass it off here. And because this is a by reference class, I can get away with forking the wire here. So ignore all this for a second. So I have my test step class, I give it the mock DMN, and then I call my test VI. So this is the VI that we just looked at. If I'm going too fast with the demo, please feel free to tell me to slow down. And then we have a verify method. So all the mock objects have this verify method, and you pass in the mock object, and you pass in a desired call log that says, this is what I want to have happen. And it compares that to what the mock object recorded. And then it outputs either a pass and a message. So this is framework independent. So you could use Karai, you could use JKIVI tester, you can use anything you want. That was one of my requirements, right? So it just outputs a pass and a message. And so here's the interesting part where I'm building the call log, and there may be a better way to do this. But right now, I have a call log is basically an array full of calls. So I create a call object called set DC volts, and this corresponds to the PIs here. So set DC volts, so that's the first call. Fab is pointing out the BITAC tool and given when then, and that is James McNally. Make sure I give James credit. Right, so first we're going to call set DC volts, then we're going to call set manual range with a range input of 10, and it pulls the name off of these as you bundle them together. Then we're going to call auto 0, then we're going to call take reading. Right, so if I run this, you'll notice it passes. Yay, everything's happy. If I get rid of one of these calls, well, actually, let me just, if I enable the other frame here, right, so now I'm not making any of the calls, and I hit run. My test failed, and it said wrong number of calls. I expected these calls, and I got back calls. Let's enable this again. Show you a few other features. So now if I say I wanted the range to be 5, right here it's setting the range to 10. When I run this, it failed, and it says it failed because call number 2 method set manual range. The parameter range it expected 5 plus or minus 0, and the actual was 10. Right? So you can see I'm verifying that all those things are called. Now, you can probably imagine that you could totally abuse this and specify the implementation of what you're doing rather than the actual behavior. So it is something to be careful about. Now I'll show you. So that was my original implementation. I added one other feature. So now I have this. There's a toolkit here. Where is it? Mock objects. So I have this, a different kind of call log that says at least one match. So what this will do is, let's just say I just wanted to make sure that the auto 0 is called, right? For example, all I cared about was the auto 0. Oops, I deleted my constant there. So by default, the matching is very strict. It's all the same calls in exactly the same order. If you insert an extra call, it fails. This just says, I just want to be verified that you called auto 0 somewhere. And that passes. And of course, if I don't call auto 0, then it will fail. Right, call 1 to auto 0, not found, nothing matched. And then if I go backwards, put all those back, there are a couple other, so there's a, you can add a numeric tolerance, and any of the numeric parameters will have a tolerance added to them. The verifying code be placed in the test code. So if someone forgets to run the unit test, so I'm not sure I understand that because I'm not quite sure I understand your question, said through, because tests are not usually run during normal operation. Tests are something that you do at edit time when you're developing, at least for me. Okay, exceptions and assertions, I think is the what yeah, I think that was the word that Fab was searching for, although I think some language probably called them exceptions as well. But yeah, assertions are what Fab was referring to. So there's that. You can also you can input a list of custom parameters. So there's some options here. Oops, I turned on context help. And where is it? Why is context help not coming on? There's context help. So you can pass in an array of custom parameters. So the way that we'll get into how this works, how that comparison is done. But basically everything dynamic dispatches on the desired, right? So the normal log just logs everything, and then the desired handles the type of comparison you want to do. So you don't have to change the mock object or anything. You just change the objects when you're building your desired call log. So you can override the default matching behavior for the log itself. You can override the default matching behavior for the call itself or the individual parameters. So you could have a parameter that says, instead of an exact string match, it could be case insensitive, or maybe it strips white space, or maybe it does a regex match or something like that. I added a tolerance for numerics, but you could add a range or a greater than or less than. So there's a lot of options there in how you do all the matching. And that's part of what this gives you by letting you pass in custom parameter types. You can also ignore some parameters. So you can say, I don't care about these couple parameters, just ignore them. So two downsides to this. One, you can see I'm setting the name here. So if you change the name of the method, you're going to break your tests. That's a problem. Also, they're relying on the name of the inputs and outputs. So that is also a problem. If you change the name of a control in the front panel, you're going to break some tests. I think the messages are good enough that you could probably find all the places that you broke it and you fix them, because it'll tell you, but I think that would cause you some problems. All right, and Fab posted a link to Peter Horn's Assert API. Michael says you might want to start a suite of tests on an executable after building it. Yes, I definitely have just gotten into PPLs, but I'm a big fan of building a PPL and then testing it, which would also be potentially running stuff in the runtime engine. Karaya for creating Assert APIs by Fab. Yes, they're going to be showing their new stuff, so that's good. There's a question on there for Steven. I will let him answer that one. All right, so this is all how you would use it and how it works. I want to dive into the code itself. All right, so I've got 3 repositories here. So there's a class refactoring library. And that includes tools to create what I was calling an interface, but it's really an abstract base class. Also includes some tools for moving stuff around classes and then relinking stuff. There is a mock object helper, and we're going to take a look at that one. And then the class refactoring tools is basically the wrapper that shows up in the tools menu that lets you access all the tools for creating mock objects. So maybe we'll get to the scripting stuff, but I think the mock object stuff itself is a little more interesting. So kind of in the design of all this, the first thing I thought was, okay, I'm going to create all these mock objects. They're all going to have to keep track of which calls were made and what parameters were passed. So I thought, well, let me start out by making a class that just does that. And then all of my mock objects can just own a copy of that class, right? So I could use composition to have all my mock objects be able to keep track of everything. And so I start out with this mock object helper. And then I also start out with a call log, right? Because the mock object helper needs to keep track of all the calls, so it should put them in a call log. And you can see that my mock object helper, I made the call log. I made a reference to the call log. And the reason I wanted to do that is because I wanted to be able to split the wire. So I wanted to be able to pass my mock object off to the code I'm testing and not have to retrieve it on the other side, right? So I pass it off, and I don't care what happens to it because it's a by reference class. They've got a reference to it. They can do whatever they want. And then at the very end, then I've still got a copy of it so that I can run the verify. So that was that first design decision. And then I had some methods. So I figured since I've got a reference to the call log, I need an initialize, right? And all this does is create the DVR. That's pretty easy. And then I need to be able to log a call, right? And so what do I need to log a call? Well, I need all the parameters that were passed in. And the name of the method I actually get from the call chain, right? So this just looks the call chain for what's calling this VI, and it grabs it, strips some stuff off, and it just gives you the name of the method. So it strips off all the LV class stuff. It strips off any library namespacing or whatever. It just gives you the name of the method. And here I'm creating a call, so I'm giving it the name of the method, and I'm giving it the cluster of the parameters, and it's creating the call object, which is holding on to that, and I'm stuffing that into my call log. And then I also have a verify call log method. And this destroys the DVR because I don't need it anymore. So that eliminates having a separate cleanup VI. And it pulls off the call log that was collected from the class itself. And I pass in a desired call log. And here, make sure desired goes to the top terminal because that is the dynamic dispatch terminal. And so that's what determines which verify that gets called. If I double click on the verify, you can see it's dynamic dispatch. I've got two different kinds. If I want the strict one, which is a default, I first look at the number of calls because if they don't match, then there's no point in going on. And if they do match, then I index each array, pull each call off and see, do these two calls match? If they do, great. As soon as one fails, I stop and say, hey, that one failed. Go do something else. Sorry, I'm just looking at the group chat. Looks like there's some good discussion there. I don't think there's any questions for me to answer. And then the one match just says, hey, for each call in the desired call log, see if there's a match in the call log that was recorded, the actual call log. And if it fails, and as soon as you find one that passes, everything passes and we're good. If you don't find one, then it fails. And that's basically the logic there. And it's pulling off the method name so that it can then log it and tell you which method it didn't find a match for. Any questions so far? Does this all kind of make sense? And I mean, I have some tests for all of these, so the tests might also help us just kind of understand what's going on. So this is log call generates a correct call log. So here I've got my log call being called here, and it's going to record the name of this VI, test call log Taggart correct call. So here I'm just pulling off the name of the VI, and I'm creating a call log here that says, I've got these parameters. This is the method. It's adding it to my list of call logs. Right, so I'm creating the log here. And when I call this here, it's as if it was being called inside a method. Then when I verify, I get the correct answer. That's what it's checking there. And then I have another test case with no parameters. So it's basically the same thing, just no parameters. And then I have a bunch of other classes associated with this. So I have a call log. So I'm testing the verify method. So if I have two calls, right, with the same name, when I verify them, they come out as the same. So I'm testing a bunch of different things here. All right. That is the basics of how all this works. What does anybody want to see? Where should we go? Should we dive into more detail on anything? Anybody have any thoughts to my questions that I asked about how to handle outputs, creating stuff on the fly, interfaces, and or any refactoring tools that would be useful? I will open up the CLA. Can I use mock objects or simulators from test-driven development for maintenance operations of a machine, like preventing maintenance or checking what broke down in the hardware? So the purpose of mock objects and this type of testing is to test your software, not necessarily the hardware. So I don't think you're going to have a lot of luck with that. I could be wrong. There could be a way to make it work, but that's really not the purpose. An analysis of the test report results. So that depends on what testing framework you use. So if you use JKI VI tester, so as an example, I can show you in my mock object helper, I have a bunch of tests. So if I just run all the tests, you'll see what a report would look like. Now, none of these are actually using mock objects themselves, but you would get a similar report. And what would come out in the text box here, I'll show you that where it says test failure data. If the test failed, then whatever comes out of the message would show up there. So it would tell you, hey, I expected this call and I didn't get it. Yeah, Mike hit the nail on the head. I'm talking about testing software, not testing hardware. It's not to say you couldn't figure out some way to make it all work. So Chris mentioned a spy, and a spy does something somewhat similar to a mock object in that a spy would, if you had a dependency and you sent it some data, right? So say you have a database and you make a call to the database and you send it some data, it would return to you what the data was that was sent. So it's kind of like recording the call and the parameters, but it really just gives you the data that was sent. So there's a slight difference there. So Mark Bremer asks, is having to heavily maintain unit tests, i.e. that they always break when you change stuff, is that a symptom of not correctly identifying a unit of behavior? I would say that is true. Or it could be changing behavior, right? So you had a certain requirement that things happen a certain way, and then you change the requirement. Well, then you're definitely going to have to change your tests, right? Now, if you change the implementation without changing the requirements, the behavior, and your tests are breaking, that means that you're testing your implementation more so than your behavior. Michael says, nothing blocks a way to use exactly the same approach to test hardware. You're correct. You can take JKI tester and write a bunch of tests that test hardware. I don't know that you would use mock objects in that situation. Maybe you would. If your hardware is simulated hardware, you could use mock objects to test your simulator. That is true. I do like Fab's comment about being a barometer of the size of changes, right? So if they tell you, oh, we just want to make one small change and it breaks 65% of your tests, that's not a simple change. That is true. Although that assumes that the tests are well written, right? Which if it's Fab, I'm going to assume that they are. But if you inherit it, maybe not. So yes, The Art of Unit Testing is a good book that Michael recommends, and I recommend it as well. I have to say, I like X Unit Test Patterns by Gerard Mazzaros a little bit more, but it's a 900-page book, so it's a little heavy. But I honestly, for whatever reason, even though it was 900 pages, I found it easier to understand. So, it was called X Unit Test Patterns by Gerard Mazzaros. Yeah, if you go on my blog and search book reviews and unit testing, you'll find several books on unit testing. So, I use black box tests and test development, similar to invest in it. I simply tell them I'll use the same code for preventive maintenance, so this is not just for me. Huh. Yeah, I mean, I think if you're doing, I'm not sure how to respond to that, Goofy Wires. Um, Maybe somebody else will have some input on that. Yes, Chris, I think you found the book. Pretty sure that probably leads to it. Yes, Chris, there is a subtle difference between unit tests and integration tests. So I think of unit test as testing the Legos individually, the blocks, and then I think of integration test as do the blocks fit together correctly. So, and yes, that was kind of what I was thinking as well about what Goofy Wires is talking about. Is sounds like more of an integration test. Uh, I'm going to try very hard not to be dogmatic. Yes, I think that's a very good. I do think integration tests though are also for you. I mean, you've got a integration test that. So I feel like unit test that I meet the interface that I've decided on. Right, I've decided this is how the API that I'm going to use, and I meet that. That's the unit test. Integration test is saying I have the correct interface more to me. But yes, unit tests are definitely more for me. I don't think that my end customer is ever going to see or care about my unit test because it's testing on a more lower level. So, yes, I do like Michael's definition that it generally just runs solely in RAM and with very few dependencies. But I would say, like, for example, my TDMS headers thing, I have some unit tests that actually touch the file system, and they're plenty fast for me, so I'm okay. Good. Yeah, integration tests are very useful. So yeah, I mean, To me, the unit tests are more for regressions and more for, as a developer, to give you the freedom to refactor stuff and feel like you're not going to break stuff. To me, that's like the biggest thing. And that's why I like the test-driven development cycle, because it's like I write a test, I write some code. Now I have this chance to refactor, and it's kind of built in there. So I really enjoy that rhythm. Other questions, comments? Anybody want to see more code? I'm happy to dive into any of this code that you want. If you want to dive into it, I suggest you start by looking at the mock object helper library. Yes, that is something Michael hit on. If you have integration tests, it really depends on what you're using to run tests. But I would suggest if you're using JKI tester, you have a separate project file that contains all your integration tests. Because when you click the run all test button in JKI tester, it will run all the tests that it finds. And if it finds your integration tests, it will run those. And you don't want to be running those all the time because generally they take longer. And they probably require access to hardware and other things. Fabiola says you can also run them programmatically. Yes, you can. When I'm doing test-driven development, I tend to just click on the button in the project, but you could have a VI that just runs one set of suites or something, and that would work as well. Well, then I think you miss out on the JKI VI tester GUI, although I guess you could probably launch that programmatically too. Yes, Fabiola brings up CI and CD, and I think that's an important topic, kind of beyond the scope of this, but I think Paul Morris, I think, did a presentation, and I think Fab was involved in that, where they had a scheme for Git and branches and CI/CD and when you run what tests and figuring all that out. And that seems very useful. Yeah, I am a big fan of running tests automatically. I'm a big fan of adding a pre-build VI to a lot of my builds that runs the tests so it doesn't waste time building it if it's not going to work. Michael is talking about finishing features and running regression tests. So, yes, CI/CD is definitely a subject for next VIWeek. I want to say a year or two ago, there was a whole ton of presentations on CI/CD stuff at NIWeek. So, Michael says unit tests should be run each commit. I don't know that I terribly disagree with that. I would say that I don't necessarily always do that, but sometimes some feature is too big for just one commit, and maybe that's me not breaking down my work well enough. When I try to do something really big, I often commit partway through just because I don't want to accidentally lose my work, and I do not run tests for those. So. I definitely do agree with Fabiola, though, in running all the unit tests before you commit to the development branch. Yeah, so Kabul mentioned Git flow. So yeah, when I'm doing Git flow and I'm on my own feature branch, I don't necessarily run the tests every time I commit. I certainly do agree. I think Fabiola mentioned, before you merge into development, yes, you definitely should. Yeah, well, Michael, I guess I do not follow 100% pure TDD. So, but yes, I kind of fall into Chris's camp. Definitely every push, you should run the tests. I probably run them more often than that, but Yeah, I'm with Steven. I think the pragmatic. And Fab posted one of her articles. She has several, so I highly recommend you go read it. All right, who else has more comments, questions? I will point out, so for my mock objects, if you've watched the video, there is a tool that basically creates the mock object for you. So you point it towards a class and it creates a copy of that class, renames it, inserts it into the hierarchy, and takes all the methods, empties them out, and puts the record or log call in there for you. So you don't have to do anything other than point it at the correct class. So, any other questions, comments? Anybody else think of a better way to do what I'm doing? Because I'm not entirely sure that the way I have all this laid out is the best way to do it from a design point of view. I'm looking mostly at Steven, but anybody else can feel free to chime in. Are Agile and TDD related? I would say yes. I mean, if you don't do TDD, can you still be Agile? I would say yes, but I would say they're closely related. Yeah, Steven, I was just thinking because you know the features of LabVIEW probably a little bit better than me, but yeah, Uncle Bob is a very good source. So is Kent Beck. Yeah, I think Kent has several books on TDD. I think TDD by example is the one that people tend to recommend. Well, thank you, Stephen. Bob Martin, Mark. Yes, and Chris Stryker is being modest. He has a very good presentation on clean code that he gave at an iWeek. So it's worth watching. Did my video freeze? Probably froze a while ago. Any other questions, comments? For those of you who've used mock objects in other languages, does this seem similar? Glad you all enjoyed it. I guess I should throw the link up there again in case anybody is interested in going to check it out. I'm happy to hang out and continue to talk, so I don't know what anybody is doing. Feel free to unmute yourselves and joining the Discord lounge. Yes, I can do that. Rethinking stuff is very good. I do that a lot. Every time I think I've got it figured out, then I discover something new and I'm like, oh, I didn't quite consider that. So I think that goes back to the Agile Manifesto thing of we are discovering better ways of doing software by actually going out and writing software. Yeah, it's good to have a link to Uncle Bob's book, Fabiola, because he has about 20 of them. So you say Bob Martin, nobody knows which one you're referring to if they're not familiar with it already. All right. Well, if there are no more questions, oops. Putnam, what's going on? All right. Well, it looks like everything's dying down, so I'm going to go over to the Discord channel and go talk to Michael. So if anybody wants to continue the conversation, you can just jump over there. So thank you.